Okay, this is section 1.6 over absolute value equations. So we're going to go ahead and skip problems 1 through 6. And I'm just going to jump down here to where we talk about uh, what it is an absolute value is. So here they kind of give you the definition of an absolute value, the distance between 2 points A and B on a number line. Now, really what we focus on is we usually say the definition of an absolute value is the distance measured from zero. Okay, so let me write that up here. So the definition of an absolute value is the distance measured from zero on the number line. Now, since we're measuring distance, we don't have negative distance. Our answer would always be positive. So if you live 5 miles on one side of the college and I live 5 miles on the other side of the college, then if we had to put that on a number line, then one of us would be representing a -5 and the other one would be representing 5. But in either case, both of us live 5 miles from the college. So the distance would always be positive. Okay, so as we look at this example, if we have the absolute value of x is equal to 4, well, that means what does x have to be that if we measure the distance, we get 4? And so here's 0. So it could either be 4 or it could be -4. So whatever is inside here could be either positive or negative. So that means that whenever we solve these absolute value equations, we're going to end up with two different equations. So it says if k is greater than 0, then the absolute value of u is equal to k is equivalent to u equals k or u equals -k. Now, if you're thinking, hold on a second, you just said that whatever was inside the absolute value would either have to be positive or negative. Okay, well, let me show you something. So if it's inside, if the inside is positive, then that would just give me u equals k, which is right here. Okay. Now, if the inside is negative and I want to solve for u, then that would give me u equals -k. And that's why we have this other part where u is equal to -k. And so when we solve these equations, the first thing that we're going to do is first we're going to make sure, because it said that k has to be positive, so k is that constant, whatever it equals. So first, you need to make sure that the absolute value, so step one, that the absolute value is isolated. Not what's inside the absolute value, but the absolute value, but that this is by itself. There's not a number in front. It's not the absolute value of x plus 5. It's not anything like that. You want the absolute value by itself. Then step number 2, does it equal a positive number? Okay, so those are the two things that we want to look at. All right, so here's how we solve this absolute value. So number 7, my absolute value is by itself. So I'm going to have two equations. Now remember, we're going to have u equals k, so whatever's inside the absolute value equals that number. And then whatever's the absolute value is equals its negative number. So since My absolute value is by itself and it does equal a positive number. We are good. So my first equation is going to be 3x equals 15. And then my second equation is going to be 3x equals negative 15. So when we quickly solve this, we're going to get that x is equal to 5 or x is equal to negative 5. Now let's plug it back in and check. 3 times 5 is 15. So the absolute value of 15 is always positive. It always comes back as positive. So the absolute value of 15 is 15. 3 times negative 5 is negative 15. But when I take the absolute value, it always comes back positive. And so it does equal 15. Okay. So my two solutions, we're not going to write this in set notation where x is a set or the set of x such that x is blah, blah, blah. We're just going to write this in our set notation. So our two answers would be negative 5 and 5. Now, in class, I know a question came up was, do I have to put this in numerical order? Could I list it as 5 and negative 5? I believe you can, but if you enter that in ALEKS, then it might come back and say that you have a form of the answer, then you want to flip it and put the smaller number first. Okay, now that I've shown you how to do that, I want you to try number 8 by yourself. So I'm going to pause the video in 3, 2, 1. Okay, so your two equations should have been 2x minus 1 equals 5 and 2x minus 1 equals negative 5. Then you solve them, and then you get these two solutions. Now, something that I did forget to tell you. Once you know that you have isolated your absolute value and it equals a positive number, when you split in your two equations apart, that's when you drop the absolute value. Do not hang on to the absolute value. When you split, let go of the absolute value, okay? Now, number 9 is an example where our absolute value is not isolated. It's not by itself. So we have to do that. So the first thing that I need to do is get rid of the 1. And the next thing I need to do is get rid of the coefficient of the 2. So this is going to be 2 times the absolute value of x minus 4 equals 6. We subtract 1 from both sides. Now I'm going to divide both sides by 2. I still cannot release the absolute value because I have to make sure that after it's all said and done that it equals a positive number. So 6 divided by 2 is 3. Now I'm safe. I have isolated my absolute value and it equals a positive number. So I'm going to split this apart into two equations. X minus 4 equals 3. And then x minus 4 equals negative 3. And these are just real easy equations to solve. And here are your solutions. Okay. All right. Now let's flip to the second page. And now remember, I told you your absolute value has to equal a positive number. So if k is less than 0, which means it's negative, so if you have the absolute value of k, but because it's negative, then you will not have a solution, because how can you take the absolute value of a number and it come back negative? Remember, the absolute value is always positive. Okay, so because this equals a negative number, then your answer is automatically a no solution. Okay, so you got to be careful with that. All right, now the second part, number 11, if k is 0, so if the absolute value is equal to 0, well, then you only have one equation. Okay, this will only give you one equation. And since if you only have one equation, then that means all you have to do is drop the absolute value and solve it. So you only have one solution, and in this case, it would be a -2. Okay, because remember, if this were a number, you would have a positive and a negative number. Well, 0 is neither positive nor negative. And even if you did try to treat it as a -0, well, -0 is still 0. So it would only give you the one equation. Okay. Now, the last problem that we look at is number 12. This one can be a little bit tricky. When you have two absolute values, all you're going to do is you're going to drop both of them, drop both absolute values, except you're going to make one of them negative. So u equals w or u equals -w. So I'm going to have 3x minus 1 equals x plus 5. And the other equation would be 3x minus 1 equals its negative x plus 5. Okay, so you can see u equals w. This is u and that's w. Or u equals negative w. Okay, so for this one, we're going to solve this real quick. So this gives us a 3. And over here, first we have to distribute. So be very careful when you distribute that negative. This is going to give us a 4x minus 1 equals -5. Add 1 to both sides. So we get that x is -1. Now let's check this to make sure. Okay, I know I don't have you do this quite often, but in this case, I want you to see how this is going to work. So we're going to check. So first I'm going to check that x is 3. All right, so we have the absolute value of 3 times 3 minus 1. Does this equal the absolute value of 3 plus 5? So 9 minus 1, that's the absolute value of 8, equals the absolute value of 8. 8 equals 8, check. Now we're going to check x equals -1. So 3 times -1 minus 1, the absolute value, does this equal the absolute value of -1 plus 5? All right, 3 times -1 is -3 minus 1. It's the absolute value. This is going to give us the absolute value of 4. So this is the absolute value of -4 equals the absolute value of 4. Well, the absolute value of -4 is just 4, and the absolute value of +4 is 4. Check. They both work. Okay, so our solution is going to be -1 and 3. Okay, and that's how that works. So it's not difficult. You just have to be careful. When you split your equations apart, do not hang on. Well, let me back up. First, again, make sure that your absolute value is isolated, and then make sure that it's set equal to a positive number. If it is, that's when you break apart your two equations. And then that's also when you drop the absolute value sign so that you can get your two equations. Once you split them, do not hang on to that absolute value sign. If your absolute value equals a negative number, it's a no solution. If it equals 0, it's one equation. And then when you have two absolute values, that's the last example that I walked you through. Okay, so let me know if you have any questions.